In this video, you will learn about the physical properties such as the boiling point, melting point, and solubility of functional groups such as alcohol, aldehydes and ketones, amines, and carboxylic acids. So let's start with alcohols. The melting points and boiling points depend on the intermolecular forces of attraction between the molecules. In alcohols, there are two types of intermolecular forces. The non-polar alkyl group, or the hydrocarbon part of the molecule, experiences only weak dispersion forces. However, the polar OH hydroxyl group forms hydrogen bonds with neighboring molecules. Recall that hydrogen bonds are much stronger than dispersion forces. Therefore, as compared to alkanes, alkenes, and alkynes of similar molecular mass, alcohols have higher boiling points because of the presence of hydrogen bonds. To compare the boiling points of primary, secondary, and tertiary alcohols of similar molecular mass, the primary alcohol has one alkyl group attached to the OH group. The OH group is surrounded by two alkyl groups in secondary alcohol, and in tertiary alcohol, the OH group is surrounded by three alkyl groups. So in tertiary alcohol, the three alkyl groups make it harder for the alcohol to form hydrogen bonds. Therefore, tertiary alcohols have the least boiling point as compared to secondary and primary alcohols. Regarding solubility of alcohols, lower alcohols such as methanol, ethanol, and propanol are soluble in water because they can form hydrogen bonds with molecules of water. But as the non-polar alkyl group gets longer, the solubility decreases because it hinders the formation of hydrogen bonds. Then we have the aldehydes and ketones. They have a non-polar alkyl group that experiences only dispersion forces of attraction, but the polar carbonyl group, that is the CO group, experiences dipole-dipole attraction with its neighboring molecules. So aldehydes and ketones can form dipole-dipole bonds. As compared to alcohols of similar molecular mass, aldehydes and ketones have relatively lower boiling point. This is because the dipole-dipole intermolecular forces are weaker than hydrogen bonds. To compare aldehydes and ketones of similar molecular mass, ketones have higher boiling points. This is because the carbonyl group is flanked by two alkyl groups, and these alkyl groups make the carbonyl group more polar, as compared to aldehydes that have only one alkyl group. Regarding the solubility of aldehydes and ketones, they are soluble in water because the carbonyl group forms hydrogen bonds with water. However, the solubility decreases with increase in size of the bulky non-polar alkyl group because it hinders the formation of hydrogen bonds. Ketones are slightly more soluble in water because the carbonyl group has higher polarity. Next are amines. Like alcohols, amines form hydrogen bonds with other amines. However, the hydrogen bonds in amine is weaker than alcohols. This is because nitrogen has lower electronegativity than oxygen. The NH bond is less polar than the OH bond in alcohols. So an alcohol will have a higher boiling point than an amine of similar molecular mass. The boiling points of primary amine is higher than a secondary amine of similar molecular mass, and the tertiary amine have the least boiling point. This is because the three alkyl groups in the tertiary amines hinder the formation of hydrogen bonds, and therefore the solubility decreases from primary, secondary to tertiary amines. Regarding the solubility of amines, the lower amines are soluble in water because they are able to form hydrogen bonds with water, but as the alkyl group increases in size, the solubility decreases. Lastly, the physical properties of carboxylic acids. Carboxylic acids have a non-polar alkyl group and two polar groups. One is the carbonyl group, that is the CO, and the hydroxyl OH group. Therefore, carboxylic acids can form two hydrogen bonds with another molecule of carboxylic acid. This results in a dimer where two molecules of carboxylic acids combine together through hydrogen bonds. And this makes the boiling point of carboxylic acids higher than amines or alcohols of similar molecular mass. For example, the boiling point of propanoic acid is higher than 1-butanol, even though their molecular mass is similar. And then we have the solubility. The carboxylic acids with smaller alkyl groups are soluble in water, but solubility decreases with increase in length of the non-polar alkyl group. The polar carbonyl group is soluble in water because it forms hydrogen bonds with it. So in the workbook, you'll get to practice questions based on these concepts. So good luck and enjoy.